Tesla coils are regarded as one of Nikola Tesla's notable inventions. The first Tesla coil was invented in 1891, in hopes to provide the world with wireless electricity and communication. Tesla was able to build the magnifying transmitter, a very massive version of a Tesla coil. However, after a series of events, investors lost confidence in his research and pulled out of the project. Today, Tesla coils remain as a source of entertainment and a viable topic of research, but not for wireless electricity. A Tesla coil is an electrical resonant transformer circuit which produces a high voltage, low current, and high frequency alternating current. It consists of a primary and secondary coil, both with a capacitor in the coil. The current flows into the primary coil and then links to the secondary coil, creating a high voltage and low current, which shoots out lightning-like discharge. The three main components of the Tesla coil includes the capacitor, the inductor, and the transformer. This video will not describe the exact schematics of the Tesla coil, as there will be many electrical engineering concepts that we are unable to cover. The capacitor used in the Tesla coil is the toroid capacitor, and it follows this complicated equation. As the exact EM formulation of the toroid capacitor is too complex and requires computational as well as theoretical experts in EM, we'll use Medher's empirical version to compute the capacitance. Thus, by adding the isotropic capacitance of a toroid and the isotropic capacitance of a coil, we get the effective capacitance for the Tesla coil. Therefore, the Tesla coil capacitor purpose is to store enough power for the Tesla coil to discharge its energy. The equation above provides us with information needed to power our own specific Tesla coil. We will now move on to the next component. The inductor stores energy using a form of magnetic field as compared to a capacitor using a form of electric field. Using previous EM knowledge, we know the flux, which is the integration of the magnetic flux density passing through an area A. The transformer is the final important component in a Tesla coil. A transformer is an electrical component whose main purpose is to reduce or increase the voltage of an alternating current. The basic physics principle behind the transformer follows its relationship with the input impedance Z, voltage V, and current I as shown in the equation. So how does a Tesla coil work? Tesla coils start when the circuit swings the charge back and forth between the primary coil and the capacitor, while the secondary coil and capacitor resonates with the former through many cycles. The primary coil transfers its energy to the secondary coil over a number of cycles until all of the energy is transferred out of the primary to the secondary or to other energy losses. Sparking occurs when the toroid is charged enough to force electrons to move to a low resistance object at a close enough proximity. This is similar to other electrostatic sparkings, for example, lightning. Tesla coils are used in large-scale experimentations, such as a full-scale aeroplane model, to test lightning attachments. Other applications of the Tesla coils are in the education and entertainment field. The dazzling lightning sparks and music that can be produced by such a device left many in awe and others curious to understand it more. In conclusion, the magic and mysteries of Tesla coils are left to be uncovered by those who are captivated by it. Perhaps, in the future, others will have an idea to actually make Tesla coils more relevant than it is today.